Hi students. In last two classes we discussed the formula of definition of Laplace transform and its standard formulas and problems. Today we are going to discuss first shifting theorem. Okay. So first of all you assume suppose f of t is a continuous function, piecewise continuous function and having exponential order of a, then Laplace transformation of f of t. Okay. So the form of the change of form is S form, so that write capital F of S. Okay, the transformation is F of S. Okay, then Laplace transformation of e to the power of at f of t. Okay, as we know, Laplace transformation of f of t is equal to integral 0 to infinity e to the power of minus st f of t dt. Okay, so that you can write this is equal to Laplace transformation of e to the power of at f of t means integral 0 to infinity e to the power of minus st into where f of t you can take e power at f of t. Okay, so e to the power of at f of t dt. Okay, so integral 0 to infinity e to the power of e power minus st, it is e to the power of at, so that we are taking e power minus s common s minus a into t. Okay, so minus st minus of plus at into f of t dt form. Okay, again you observe this is s minus a. Okay, so s minus a equal to, you can say this is equal to u form. So integral 0 to infinity e to the power of minus ut f of t dt form. Okay, so this is similar to same Laplace transformation of f of t integral 0 to infinity e to the power of st f of t dt. Instead of s we are having u. Okay, so this is equal to a form of g of s or f of s, capital F of s, f of u form. Okay, so it is s form is we are taking f of s, it is u form, so that we are taking capital F of u. So this is equal to f of where u is s minus a, so s minus a. Clear? So the shifting theorem is if Laplace transformation of f of t equal to s minus c f of s, then Laplace transformation of e to the power of at into f of t equal to f of s minus a. This s is replaced by, shifted by, s is shifted by s minus a. Okay, so you take one note. Okay, so this is a plus a, so that we here is s minus a. Laplace transformation of e power 8 minus at f of t equal to f of s plus a. Okay, so whenever we have minus at, this is s plus a. Okay, so shifting theorem is Laplace transformation, if Laplace transformation of f of t equal to f of s, then Laplace transformation of e power at f of t equal to f of s minus a. S shifted to s minus a. Suppose it is minus at into f of t, s shifted to s plus a. Okay. For example, of e to the power of 2t into sine 3t. Okay. So before finding Laplace transformation of e power 2t into sine 3t, we know sine 3t Laplace transformation. Okay. So transformation of sine 3t is Laplace transformation of sine 3t is 3 by s square plus 3 square. Okay. This is our f of s. Laplace transformation of e power 2t into sine 3t. So shifting. Okay. So first shifting. So f of s shifted to f of s, s plus a. This is plus c plus 2. So s minus 2. So f of s minus 2. That means this is equal to 3 by s square plus 3 square, where s value shifted to s minus 2. Okay. So this is equal to 3 by s plus 2, s minus 2 whole square plus 3 square. Okay. You can simplify here. 3 by s square minus 4s plus 4 plus 9. Okay. So this is 13. So Laplace transformation of e power 2t sine 3t equal to 3 by s square minus 4s plus 13. Okay. Similarly, you can take another example. Transformation of e to the power of minus 3t into t cube. Laplace transformation of t cube. Okay. So we know Laplace transformation of t cube is 3 factorial by s to the power of 3 plus 1. That is 6 by s power 4. Say this is a capital S. Okay. Then using this first shift theorem, Laplace transformation of e power minus 3t t cube is, so it is 6 by s power 4. Laplace transformation of t cube is 6 by s power 4, where s shifted to, okay, s plus 3. So here is minus 3, therefore it is shifted to s minus of minus 3, that is s plus 3. So you can replace s by s plus 3. So 6 by s plus 3 whole power 4. Okay. Therefore, Laplace transformation of e power minus 3t t cube is 6 by s plus 3 whole power 4. Okay. Similarly, sine or cos. Okay. Cos 5t. So cos 5t means then Laplace transformation of cos 5t s by s square plus 5 square. So this is a capital F of s. Okay. So we need e to the power of minus 3t cos 5t. That means f of s, where s shifted to 3 minus 3 s plus 3. Okay. So s by s square plus 25. 5 square is 25. Okay. So it is shifted, s shifted to s plus 3. Therefore it is s replaced by s plus 3 by s plus 3 whole square plus 25. Okay. Then Laplace transformation of e to the power of minus 3t cos 5t equal to s plus 3 by s plus 3 whole square plus 25. Okay. Like whenever you have a Laplace transformation of a function of a product of e to the power of minus at and f of t is, then Laplace transformation of f of t and s shifted to s plus a. Okay, just you replace and solve the problem. Next one, unit step function or Heaviside unit function. Okay, so the unit step function or Heaviside unit function is denoted by u of t minus a or h of t minus a. So defined by when t minus a greater than 0, its value is 1. When t minus a less than 0, its value is 0. Okay. So t minus a greater than 0 means t greater than a. And t minus a less than 0 means it is t less than a. Okay. So you observe the graph of the function is, okay. So t, and it is ut form, ut or ht function. Okay. So it is a t. When t equal to a, here t equal to a. When t value less than a, when t value less than a, it is 0. Okay. So its value is 0. Next, when t greater than a, its value is 1. So more than a, its value is 1. Okay. Observe, it is a stepping, so that it is called as step function, having unit, defined by unit. Okay. So t greater than a, its value is 1. T less than a, its value is 0. Okay. Function is the step function. To find Laplace transformation of unit step function. Okay. As we know, u of t minus a equal to unit step function equal to 1 when t greater than a, 0 when t less than a. Okay. When t less than a. So by definition of Laplace transformation, L of f of t equal to integral 0 to infinity e to the power of minus st f of t dt. Okay. So integral 0 to infinity, where f of t is unit step function. Okay. E to the power of minus st into u of t minus a dt. Okay. Again, it is a piecewise continuous function. Okay. So you split the interval 0 to a and a to infinity. So this is equal to integral 0 to a e to the power of minus st u of t minus a dt plus integral a to infinity e to the power of minus st u of t minus a dt. Okay, as we know, when t lies between 0 to a, it's 0 to a. Okay, its value is 0. So 0 to infinity, 0 into e to the power of minus st into 0 dt plus 0 to a to infinity e to the power of minus st into t minus t greater than a, it is 1 into dt. Okay, so first value is 0, second value is 0 to infinity e to the power of minus st into dt. Okay, because t minus a value is 1. Okay, so this is equal to e to the power of minus st integration is e to the power of minus st by minus s within boundary 0 to infinity, a to infinity. So here s value is greater than 0, we know. Okay, since s value is greater than 0, e to the power of minus infinity minus e to the power of 0 by, it is minus s. Okay, so as s tends to infinity, st tends to infinity, and minus st tends to 0, so its value is 0. 0 minus 1 by minus s equal to, okay, e to the power of a. So e to the power of as minus as. So minus e to the power of as by s minus as by s. Okay, Laplace transformation of unit step function t minus a equal to e to the power of minus as by s. Second shift theorem. Laplace transformation of f of t is capital F of s, you can say, and g of t is defined by f of t minus a and t greater than a, 0 when t less than a. Okay, then Laplace transformation of g of t equal to e to the power of minus as into f of s, where f of s means Laplace transformation of f of t. For example, g of t is defined by cos of t minus a. Okay, f of t minus a place is g of cos of t minus a, where a equal to pi by 3, where a equal to 5 by 3. So that we know Laplace transformation of cos t. Okay, so Laplace transform of cos t equal to s by s square plus 1 square. Okay, this is capital F of s. Then Laplace transformation of g of t equal to, okay, e to the power of minus as. So e to the power of minus as into capital F of s. Capital F of s means Laplace transformation of f of t. So f of t means where f of t is cos t. Okay, so Laplace transformation of cos t. Laplace transformation of cos t is e to the power of minus as into cos t is s by s square plus 1 square. Okay, this is the required Laplace transformation of g of t, or is equal to e to the power of where a is pi by 3. Okay, so minus pi by 3 into s into s by s square plus 1. Okay, so Laplace transformation of, okay, cos t minus pi by 3, where t greater pi by 3 and it is 0, t less than pi by 3 is s by s square plus 1 into e to the power of minus pi by 3 into s. So then Laplace transformation of f of at. Okay, so just we find Laplace transformation of f of at. So Laplace transformation of f of t. So as we know, Laplace transformation by using Laplace transformation definition. So L of f of at, okay, integral 0 to infinity e to the power of minus st into f of at dt. Okay, so take at equal to x. Okay, so a into dt equal to dx. As t tends to 0, change the boundary values. As t tends to 0, x equal to at, so 0 into a, so x also tends to 0. So t tends to infinity, x also tends to infinity into a. So infinity. Okay. So this becomes integral 0 to infinity e to the power of minus s into t value is x by a. X by a into f of x into dt value is dx by a. Okay, dx by a. Okay, so this is equal to 1 by a into integral 0 to infinity e to the power of minus s by a into x f of x dx. Okay, so instead of x we are having s by a. Instead of t we are having x. So this represents Laplace transformation definition. So this is equal to 1 by a into Laplace transformation of, okay, x, f of x. This is equal to 1 by a into Laplace transformation where f of x is defined by capital F of s. Okay, s replaced by s by a. S by a. Okay. Clear? So Laplace transformation f of t equal to f of s. Then Laplace transformation of f of a t equal to 1 by a into f of s by a. S replaced by s by a into 1 by a. Okay. For example, you observe Laplace transformation of cos 3t using change of scale property. Okay. So before that we know transformation of cos t equal to s by s square plus 1 square. You say this is equal to capital F of s. Then, so here the multiplication is 3t. So 3t. Okay. So by change of scale property, Laplace transformation of cos 3t equal to, okay, 1 by a into 1 by 3 into f replaced by, okay, f of s. In f of s replaced by s by 3. So you can place s by 3. Okay. 1 by 3 into s replaced by s by 3 by s square means s by 3 whole square plus 1 square. Simplify. 1 by 3 into, okay, s by 3 into, okay, in the denominator it is s square plus 3 square. So 3 square LCM is 3 square. Okay, 3 square by 3 square. Okay, 3 get cancelled. Okay, 3 also get cancelled. So it is equal to s by s square plus 3 square. Okay, Laplace transformation of cos 3t. Already we know Laplace transformation of 3t equal to s by s square plus 3 square. Okay, this is also derived using change of scale property. Okay, Laplace transformation of f of t equal to capital F of s. Then Laplace transformation of t by a equal to, okay, reverse, a into f of as. A into f of as. For example, okay, Laplace transformation of f of t by 3. So take e to the power of or sine 3 by t by 3. Okay, as we know, Laplace transformation of sine t equal to, okay, 1 by s square plus 1 square. But t replaced by t by 3. Okay, so Laplace transformation of sine t by 3 equal to a into, a means 3 into, okay, this is capital F of s. F of s replaced by f of s where s replaced by at and 3t means 3t. Okay, so this is equal to 3 into 1 by 3t whole 3s. Okay, 3s whole square plus 1 square. Okay, you take 3 square as common. 3 square as common. Okay, so 3 by 3 square as common. 3 square into s square plus 1 by 3 square. Okay, 3 get cancelled. 1 by 3 into s square plus 1 by 3 whole square. Clear? So Laplace transformation of sine t by 3 equal to 1 by 3 into s square plus 1 by 3 square.